Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 7 from chapter number 1, Measurements. In the previous lecture we have discussed about uncertainty, types of uncertainty, assessment of uncertainty in calculations, and some examples related to assessment of uncertainty in final result. Today we will discuss about dimensions of physical quantities, application of dimensional analysis, limitations of dimensional analysis, and some simple examples related to dimensions. Dimensions is a new concept for you people, but it is not very much difficult. It is a very interesting concept. So let's discuss what are basically dimensions of physical quantities. So how we are going to define the dimensions? Dimensions are basically expressing a physical quantity in terms of base physical quantities by using a special symbol within square brackets. Just like we were expressing units, derived units in terms of base units, just like that we are having some basic dimensions, and then we can write all other dimensions in terms of base dimensions. So this is very simple thing. Dimensions describe the physical nature of quantity. So what is the meaning of dimension? It is telling us about the physical nature. What is the nature of the quantity? Okay, whether it is length, whether it is mass, whatever the physical quantity is. So dimension is used on the basis of physical nature of a quantity. Each basic measurable physical quantity is represented by specific symbol and written within square bracket is called dimension of physical quantity. So every basic quantity is having its own dimension, its own specific dimension, in terms of which all the dimensions of derived quantities can be written. Each of 7 base quantities used in SI has its own dimension. How? We are having 7 base quantities and they are having their own dimensions, which are known as fundamental dimensions. So let's check it out. Length, first base quantity, it is having symbol capital L, and the notation with which we are representing the dimension, it is square bracket. Okay, we have to write down capital L within square bracket, and we will use simple font. We will not use any stylish font, we will not use italic, just straight L. We have to write capital L, but it should not be in any stylish form. It is sans serif format. Okay, so length is having dimension capital L, mass is having dimension capital M written within square bracket. Time is having dimension capital T, again written within square bracket. This square bracket is representing the dimension. Electric current, that is capital I within square brackets. Thermodynamic temperature, capital theta within square brackets. Amount of substance, capital N within square brackets, and luminous intensity, capital J within square brackets. So these are 7 base quantities and their dimensions. So these are basic dimensions which will be used further for all the derived quantities as well. Okay, so dimensions is basically telling us about the nature of the quantity. It is independent of all other factors. For example, if we are having distance, we are measuring distance, we are measuring length, we are measuring height, width, thickness, displacement, all these things we are measuring in different units. Some are having unit of millimeters, some are having unit of miles, some are having unit of meters, but all of these may have different units, but their dimensions are same. Capital L within square brackets, because their physical nature is same. All of these things are representing the length, the distance. Okay, so all of these are having same nature. That's why we will be using same dimension for all. Okay, we will represent all these things with capital L. That will be its dimension. So it is independent of its unit. Whatever the magnitude is, whatever the unit is, it doesn't matter. we just have to write down its dimension. Okay, so if we are talking about dimensions of derived quantities, just like as derived quantities are product of base quantities, so the dimension of derived quantities are the product of dimension of base quantities. Simple is that. Just like we are multiplying the units, base units, to get derived units, just like that we will be multiplying basic dimensions to get dimensions of derived quantities. For example, area, the formula of area is length multiplied by width. So length and width are basic quantities, so both are having dimension of length, capital L. So to get the dimension of area, we will be writing capital L within square bracket multiplied by capital L, that will give us capital L square. So dimension of area is basically the product of dimension of length. So we can find out dimension of derived quantities as product of dimension of base quantities. The dimensions of any derived quantity is written as product of powers of the dimension of base quantity. Again, same thing, we can write dimension of any derived quantity with the product of powers of the dimension of base quantity, just like we have done in the case of area, that was power of length. Okay, so if we are having different derived units, we can multiply all those derived units with some specific power. Okay, generally dimension of any physical quantity can be written as dimensions of any 7 base quantities with some power, like capital L raised to power alpha, capital M raised to power beta, these are general powers. Capital T raised to power gamma, capital I raised to power sigma, capital theta raised to power epsilon, capital N raised to power zeta, capital J raised to power eta. So these exponents alpha, beta, gamma, sigma, epsilon, zeta and eta and epsilon are, here it should be eta. These are called dimensional exponents. Okay, so these 7 are known as dimensional exponents. Okay, in dimensions, in the representation of dimensions, the magnitudes are not considered. We are not concerned with the magnitude. For example, if we are discussing about initial velocity, final velocity, average velocity and change in velocity, okay, all these velocities, they and speed as well, they are representing same physical nature. Whatever their magnitude is, it does not matter. All of these are equivalent, they are having same dimensions. We will check out what is the dimension of velocity, but all of these are having same dimensions. Okay, so let's discuss some terms which are used with dimensions, some basic terms which you should know. First one, dimensional variables, the physical quantities which have the dimensions of variable magnitude are called dimensional variables. Okay, all those physical quantities which have dimensions as well as their magnitude can be changed, they are known as dimensional variables. For example, force, energy, acceleration, all these are having dimensions, they are having units as well as they are having variable magnitude, their magnitudes are changing. So we can say that these physical quantities are dimensional variables. Second thing is dimensional constants, the physical quantities which have the dimensions but are constant in magnitude are called dimensional constant. They are having dimensions but their magnitude is not changing, that is fixed, just like universal constants. For example, speed of light, it is having a unit, it is having a dimension of velocity but its magnitude remains constant. Planck's constant, it is again having some units, so it is having some dimensions but its magnitude remain constant. Gravitational constant, acceleration due to gravity, all these are dimensional constants because their magnitude remains same and they are having some dimension, so they are dimensional constant. Then we are having dimensionless variables, the physical quantities which have no dimensions but variable or changing magnitude are called dimensionless variables. Okay, so those quantities which are not having dimensions but their magnitude is changing. They are known as dimensionless variables. For example, plane angle, as we have already discussed this thing, that in the end we are having no base unit for plane angle. The units are cancelling because it is the formula is theta is equal to s over r. It is the ratio between two similar quantities, so it is basically a dimensionless variable. Solid angle, again same thing, ratio between two similar quantities, so it is having no units, so it is a dimensionless variable. We are having radian and steradian as units, but they are having they cannot be expressed in terms of base unit, so it cannot be expressed in terms of basic dimensions as well. So we say that strain, again it is a dimensionless constant. It is the ratio between two similar quantities, just like change in length divided by length. So again it is a dimensionless variable. Then we are having dimensionless constants. The physical quantities which have no dimensions but are constant in magnitude are called dimensionless constants. Means they are having no units and they cannot be changed, just like simple numbers which we are using, pure numbers. Okay, they are having no unit, no dimension, and they are fixed in magnitude as well. The number pi, all these fixed numbers, they are basically known as dimensionless constants. Okay, then dimensional formula of physical quantity. Just like we express the unit of any physical quantity, any derived quantity, just like if we are expressing that quantity in terms of formula, we are writing within the square brackets, that will be known as dimensional formula. So we can say the dimensional formula is defined as the expression of the physical quantity in terms of its base units with proper dimension. We are expressing any physical quantity in terms of base units, that will be known as its dimensional formula. Simple is that. It tells how and which of the base quantities represent the dimensions of a physical quantity, just like units. Okay, it tells how and which of the base quantities represent the dimensions of a physical quantity. For example, dimensional formula of force. If we are going to write down the dimensional formula of force, then what we are going to do? Dimensional formula of force is mLT minus 2. Keep this in mind that it is an expression, so we will not write it as dimension of F is equal to this. Okay, we will not use equality sign over here. We will simply write its formula within square brackets. That will give dimensional formula, because F is equal to MA, so that will be having a dimensional formula written like this, mLT minus 2. It's because the unit of force is Newton or kilogram meter per second square. Okay, so we are using the dimension of mass, we are using the dimension of length with a dimension of time raised to power minus 2, because it is per second square. So we will discuss that in detail, that how we are going to write it. Dimensional formula of volume is m raised to power 0 L cube T raised to power 0. Okay, why we are writing it as m raised to power 0 and T raised to power 0? Because we have discussed this thing that while we are writing the dimension of a physical quantity, we can express it in terms of base dimensions like L raised to power alpha, m raised to power beta, and up to so on. But we are having three basic dimensions which we will use most often. These are dimension of length, mass, and time. So that's why we are expressing this dimensional formula in terms of length, mass, and time, L, M, and T. That's why we are writing m raised to power 0, because mass is not used in volume. That's why we are writing it as m raised to power 0, which will simply give us 1. That will make no effect on this formula. That's why we are writing it like this, m raised to power 0, L cube, and T raised to power 0. That will simply give us L cube. Okay, so dimensional formula is most of the times written in terms of three basic dimensions, L, M, and T. Okay, dimensional formula of some physical quantities. If we are going to express that, dimensional formula of a physical quantity can only be written when its relation with other physical quantities is known. We can only write down the dimensional formula if we know the relation with other physical quantities. Okay, if we know the relation with other physical quantities, then we can write down the dimensional formula, otherwise it is not possible. Okay, Like if we know the formula of force F is equal to ma, then we can write its dimensional formula. If we don't know the formula, then we cannot write dimensional formula as well. Some of the physical quantities with the dimensional formula are given as follows, like dimensional formula of velocity v is equal to L t raised to power minus 1, because its formula is d over t, that's why we are writing it in this form. Dimensional formula of A, L t raised to power minus 2 meter per second square. Dimensional formula of momentum, dimension of mass multiplied by dimension of velocity, that will give you within square bracket ml t raised to power minus 1. Dimension of v square, it should be square, we can write it as L t raised to power minus 1 whole square. Okay, we are taking square of the dimensions of velocity, so square is applied on both quantities. L raised to power L square t raised to power minus 2 within square bracket, that will be the dimension of v square. All these things can be written like this. Okay, that is a simple concept, nothing very much difficult. Okay, what is dimensional equation? Basically, if it is equation, then there must be an equality sign. An equation containing physical quantities with dimensional formula is known as dimensional equation. Okay, we have already written dimensional formula. While we are equating that dimensional formula with the quantity, that will give us dimensional equation. Dimensional equation is obtained by equating dimensional formula on right hand side and dimensional on the value of that physical quantity on the left hand side. Okay, so we can equate, we will use equality sign to give dimensional equation. So dimensional equation is an equation which represents the dimensions of a physical quantity in terms of the base quantity, just like a formula, simple formula. Dimensional equation is telling us about the relation between the quantity and its in terms of base quantities. Okay, it can be obtained from the equation representing the relation between the physical quantities. Again, same thing, if we know the equation, exact formula, then we can write their dimension and we will get dimensional equation. Okay, for example, if we are considering dimensional equation of force, we know that equation of force is F is equal to ma. Okay, by Newton's second law, we can say that F is equal to ma. So what we will do now, we will apply dimensions on both sides. We will write it as square brackets, dimension of force is equal to dimension of mass multiplied by dimension of acceleration, and in multiplication we can write both quantities within a single square bracket. Okay, so dimension of force is equal to dimension of mass multiplied by dimension of acceleration. Dimension of mass, we have already discussed this thing, that it is capital M. Okay, the symbol which is representing dimension of mass, it is capital M. Dimension of acceleration, it is L t raised to power minus 2. Okay, we can write down its dimension from its formula meter per second square, so L t raised to power minus 2. By putting these values from equation 2 and 3 in equation 1, we will get dimension of force is equal to ml t raised to power minus 2. So it is basically dimensional equation of force. We have discussed initially dimensional formula of force, only right hand side was written over there, but now we are discussing about dimensional equation. That's why we are using equality sign over here. Dimension of force is equal to ml t minus 2. Dimensional equation of velocity, in the same way we can write down the basic equation of velocity, which is distance per unit time. V is equal to d by t. So by applying dimensions on both sides, we will get dimension of v is equal to dimension of d divided by dimension of t. Okay, so we can write it as dimension of d is capital L, dimension of t is capital T. So we can write as dimension of v is equal to dimension of L divided by dimension of t. Keep this in mind that we cannot use a single bracket for these two terms because these are in numerator and denominator. So we have to use separate brackets for both the terms. We cannot use a single bracket over here. In division, we cannot use a single square bracket. We have to use separate square brackets for this. Okay, we can write it in the form of multiplication. This t will move to numerator and it will become t raised to power minus 1. So dimension of velocity is equal to lt minus 1. Okay, so dimensional equation of velocity, dimension of v is equal to m raised to power 0 L LT minus 1 within square brackets. Why this m raised to power 0? Again same thing, that we are expressing the dimensional equation or dimensional formula in terms of three basic dimensions, m, l and t. Okay, so now if we are going to discuss dimensional analysis. What is dimensional analysis? Using the methods of dimensions is called dimensional analysis. So if we are using a way of dimensions to find something, that will be known as dimensional analysis, and it has various advantages and uses which we will discuss now. Advantages of dimensional equation, how we are going to use this dimensional analysis, where practically we are using it. We can check the correctness of a physical relation, also called principle of homogeneity of a physical equation. We can check out whether a given formula is correct or not. We can use dimensional analysis over there. We will discuss that later on. To derive the relation between various physical quantities, we can derive a relation, not exact formula, but we can derive the relation between various physical quantities which are provided. We can also convert value of physical quantity from one system of unit to another system by using dimensional analysis. If one system of unit is given, we can find out the other system of unit. Okay, we are not going to discuss that in detail, but rest of the uses we will discuss. We will do the examples related to that. To find the dimensions of constants in a given relation, so we can find out dimensions of constant in a given relation with the help of dimensional analysis. We will also do this in example or numerical. Okay, so what is principle of homogeneity of dimensional equation? According to this principle, the dimensions of fundamental quantities on left hand side of an equation must be equal to dimension of fundamental equations on the right hand side of that equation. How we are going to apply this? We will first find out the dimension on left hand side, and then we will find out the dimension of right hand side of the given equation. If these two dimensions are giving the same result, then the equation is correct, otherwise it is incorrect. Okay, for example, if we are having a given equation of motion, Vf is equal to Vi plus At, and we want to check out whether it is dimensionally correct or not, then what we have to do? We will first consider its left hand side, Vf. We will find out its dimension. We know that dimension of velocity is equal to m raised to power 0 Lt minus 1 within square brackets. If you forget the dimension, then you can write down its unit, and from that you can write down its dimension. So meter per second, that will give you the dimension m raised to power 0 Lt minus 1. Name it as equation number 1. This is left hand side. Now we will find out the dimension of right hand side, that is Vi plus At. As dimension of Vi, that will be similar to that of Vf because it is independent of the magnitude. So dimension of Vi is equal to m raised to power 0 Lt minus 1. Okay, and dimension of acceleration, that is m raised to power 0 Lt raised to power minus 2, and dimension of t, that is equal to capital T. So by putting all these values in the right hand side of the given equation, we can write it as dimensions within square bracket m raised to power 0 Lt minus 1 square bracket closed plus m raised to power 0 Lt minus 2 dimension of acceleration multiplied by dimension of time, that is capital T within square brackets. Okay, in multiplication we can combine the values if their bases are same. So we are going to combine this capital T m naught Lt minus 1 plus, in second term we are combining T m raised to power 0 Lt raised to power minus 2 plus 1, because it's, if bases are same then powers are added. So that will give us m raised to power 0 Lt minus 1 square bracket closed plus square bracket m raised to power 0 Lt minus 1. These two are similar quantities, so they can be added. We can write it as 2 m raised to power 0 Lt minus 1. In dimensional analysis, we have already discussed this thing, that dimensional constant they are having, dimensionless constant, they are having no dimensions. So 2 over here is dimensionless constant. We can ignore it while doing the dimensional analysis, so it doesn't matter whether we are writing it or not. Okay, so we can write it as m raised to power 0 Lt minus 1. That will be equation number 2. So from equation number 1 and equation number 2, we will say that left hand side is equal to right hand side So we will say that this equation Vf is equal to Vi plus At is dimensionally correct. Left hand side and right hand side are having same dimension, so this equation is correct. If these left hand side and right hand sides are giving different dimensions, then that will be incorrect, but right now it is equal, so these two sides are equal, so this relation is correct, this equation is correct. Okay. So while we are writing the dimensions, we are having two ways to write it down. First one, by using the formula which we have already discussed, like if we were finding the dimension of force, F is equal to ma, we have written the formula, we have written the dimension of those quantities which were used in the formula, and then we derived the dimension. Second way is by using the units. We can, instead of writing the formula, if you forget the formula and you just know the unit, then you can also write down the dimensions by using units. Okay. So how we are going to find out dimension of force with the help of units? We will write down the unit of force, which is Newton. We know that Newton is equal to kilogram meter per second square. Okay, because F is equal to ma, so Newton is equal to kilogram meter per second square. If we don't remember the formula of any physical quantity, we can just write down its unit. And then kilogram is unit of mass, so dimension of kilogram will be capital M. M is unit of length, so dimension of M is equal to capital L. S is the unit of time, so dimension of S is equal to capital T. By putting all these values in the given unit, we will write it as dimension of kilogram meter per second square is equal to ml t raised to power minus 2. Okay, so kilogram meter per second square is equal to ml t raised to power minus 2. We have calculated dimensions with the help of units, which is giving us same result as that of formula. So these two ways can be used, both are correct to find out the dimensions. So if we know the base units, if we know the formula, you can find out their dimensions. But the use of dimensional analysis is also having some limitations. Okay, some limitations that it is not giving us any information about the dimensional constant. Okay, it is not giving us that what is the constant used over here. Okay, if a quantity depends on more than 3 factors having dimension, the formula cannot be derived. It becomes very much complicated and we cannot derive the formula. Okay, if we are having more than 3 quantities, 3 factors which we are using over there, we cannot derive the formula containing trigonometric functions, exponential functions, logarithmic functions. We cannot derive such type of formula with the help of dimensional analysis. Dimensionally correct equation need not be physically correct equation. It doesn't matter that if a dimensionally correct equation is there, so it need not be physically correct, because there are some things which cannot be calculated with the help of dimensional analysis. So we cannot say that if an equation is dimensionally correct, that is also physically correct. Okay, the exact form of relation cannot be developed when there are more than one part in any relation. Means if we are going to add or subtract or divide 2 or more factors, then dimensional analysis is not giving us any information about that. It is just telling us about the dependence, whether it is directly dependent on the given factor or inversely dependent. It is telling us about the power. So it is telling us about the relation, but not exact form of relation. And it gives no information whether a physical quantity is scalar or vector. It is not telling us any information. It is not giving us any information related to direction. It does not distinguish between physical quantities having same dimensions. Like we have already discussed that if we are having initial velocity, speed, final velocity, average velocity, whatever is there, it is not distinguishing between them, and whether it is length, whether it is thickness, height, whatever is there, we will be just having the same dimension for that. Okay, it is not giving any difference between those values which are having same physical nature. Okay, so girls, now you have to find out the dimension of these basic terms. Work, either you can do it with the help of formula or you can do it with the help of unit. It's up to you. So you have to find out dimensions of work, pressure, centripetal force, power and kinetic energy. You have to practice it. So up till now we will just do it up to this point. In the next lecture, inshallah, we will discuss about we will analyze about the numerical problems related to dimensional analysis. Up till then, you have to practice these. I would like to end my lecture with this quote that everybody is a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. So everyone among you is a genius. Everyone is having his or her own speciality. So you are also having your own speciality. Just believe in yourself. Okay, never judge a fish by its ability to climb a tree. So just believe in yourself, find out your speciality. You are also a genius, but the key point is that you must work hard. Okay, you have to work hard. You can do whatever you want to, you can achieve your goal. Best of luck. That was all for today's lecture. Thank you so much.